Hello everyone, in this tutorial we're gonna solve level 6 of Ethernaut, which is called Delegation. So first of all, let's get a new instance first. Okay, what is the objective of this level? The objective is to claim the ownership of the contract. So let's have a look at our contracts. We can see that there are two contracts here. One of them is called Delegate and the other one is called Delegation. So we are required to take ownership of the delegation contract. Let's check its owner first. And this is my address stored in player variable. You can see that the two addresses are different, so I am not the owner yet. So let's explore delegate contract. Delegate contract contains a state variable called owner of type address, and it is the first state variable in the contract, which means the value that will be stored inside it will be stored inside slot 0. And there is a constructor to set the owner address, and there is a function called pawn that also sets owner to the message.sender. And inside delegation contract we also have a state variable called owner that is of type address, and it is the first state variable in the contract, which means the value inside it will be stored at slot 0 as well. And there is a reference to the delegate contract. It sets the reference to the delegate contract address at the constructor, and it sets the owner as well. This function has a fallback method. What is the fallback? The fallback method is executed in one of two scenarios. If you call this contract with empty call data and there is no receive function, or if you called the contract with call data but the function signature inside the call data doesn't match any function selector in the contract. So what does this fallback do? It makes a delegate call to the delegate contract and it passes to it the message route data. So what is a delegate call? A delegate call in Solidity is a low-level function, but if contract A makes a delegate call to contract B, it means that the code will be executed from contract B, but it will be executing in the context of contract A. So the transaction will be executing in the storage of contract A. So for example, if we were able to call the pawn function from the delegation contract, it means that when this line executes, it will update the owner of the delegation contract, not the owner of the delegate contract. Why? Because both of them are at slot 0. So Solidity depends on the order of the state variables. Each one is put in a slot. So it will update slot 0, but of the delegation contract, not of the delegate contract, because of this delegate call function. What if this owner state variable was called XYZ? It doesn't matter. It will also update it, because it doesn't matter the state variable's name with Solidity. It's all about the order of the state variables and the slots. So what does a delegate call takes as a parameter? It takes a function signature to call it. So how can we get the function signature of the pawn function in order to call it from this fallback method? We can use something called API include function signature. It takes the function name along with the parameter types and it gets you back the function signature. So what is the function signature? A function signature is you get SHA-3 hash of the function name and its parameters types, and then you slice the first 4 bytes, which is the first 8 hex characters. So let's try this in our console here. web3.utils.sha3. You can give it a function name and its parameters to get you the SHA-3. Look, what is the function signature here? The function signature is the first 8 hex characters. So what if I wanted to get SHA-3 of this function? I will do it like this. So instead of using SHA-3 right away and slicing the first 8 characters yourself, you can choose include function signature right away. So this is the function signature that I need to pass to the message root data in this transaction. How can we do this? Let's call contract.send transaction and pass call data to it. So what's happening right now is that when you send a transaction to this contract with this data doesn't match any function selector in the delegation contract. So it calls the fallback. When it calls the fallback and executed, it makes a delegate call to the delegate contract with the message root data here, which is the function selector or the function signature of the pawn function. This function will be executed but using a delegate call, so this owner address is the one to be updated. Now let's check the contract owner again. Let's check our player address first and the contract owner. We can see that now I am the owner of the contract. Let's submit the instance. Well done. So that's it. We learned about the delegate call and how it works. Thanks for watching. See you in another tutorial.